Okay, this is Algebra, section 12.1, probability outcomes. Probability is the study of the chance that something will happen. If your probability is 0, that means an event is impossible. If a probability is 1, that means an event is certain, it will happen. And you can have anything in between, so like a 0.5 or 50% or half, either way you want to say it, means that something is equally as likely to happen as to not happen. You can give your probabilities in fractions, in decimals, or percents. That's totally up to you, and in some situations one way makes more sense, in some situations a different way makes more sense. And so outcomes, that's just our fancy word for possibilities. When you calculate how many possibilities, when you add up how many possibilities there are, that's going to be the bottom number of your fraction. So like if I'm talking about how many ways there are to roll a number on a die, I have 6 possibilities, 1, 2, 3, 4, 5, 6, and so that would be the denominator of my fraction. So if I'm rolling a die, 1, 2, 3, 4, 5, 6 as my possibilities, then the probability of any one of those outcomes, let's say the probability of rolling a 2, would be 1 out of 6, because one of those possibilities, one of these possibilities right here, is a 2 out of the 6 possibilities. Okay, so let's do some examples. The first example says a jar has 10 suckers, 3 cherry, 5 grape, and 2 root beer. 1 sucker is drawn at random. Find the probability. So the probability of a grape sucker, if I have 10 suckers, that means it's going to be out of 10. And how many of those 10 are grape? 5 out of 10 are grape. So here's a nice fraction. We could also reduce that fraction. We could say 1 out of 2. We could also divide that fraction to get a decimal, which is 0.5. We could also change that to a percent, which would be 50%. Now you don't have to give all of these answers. I would probably just leave it like this, but all 4 of those answers are right. What's the probability of having a cherry or grape? So if I look up here, I have 3 cherries and I have 5 grapes, and I'm going to put those together. 3 and 5 makes 8 out of 10. So again, you can reduce this to 4 out of 5, or you can divide it to get 0.8, or you can make it a percent, 80%. All of those are correct. The probability of not getting root beer. Well, if I look here again, here's root beer. I have 2 root beers. So I can say 10 minus 2 gives me 8. Or I could say these are not root beers. 3 and 5 put together makes 8. Either way, I get 8 out of 10. Letter B says, consider the graph at right. What is the probability that the next person you meet will have type O blood? If I look for the region with type O blood, it says that there are 43% of the population. So my answer is 43%. And again, you can percent it, you can fraction it, you can decimal it. It's totally up to you. In this situation, I think it's easier to just leave it as a percentage. What is the probability that a person does not have type A blood? I can find type AB. I can find type AB, and I can say that there's 5% that has it out of 100%. That means 95% doesn't have it, because 100% minus 5% leaves me with 95%. I could also go the longer way of adding everything else up. If I add up 12% plus 40% plus 43%, I'll get the same answer, 95%. And letter C says, in a city of 75,000 people, how many people have type A blood? Here I have 40% have type A blood. So what I need to do is 40% times 75,000. Now, if you have a percent button on your calculator, you can type 40% times 75,000. If you don't have a percent button, you'll probably have to convert to a decimal or a fraction. But either way, you're still going to multiply by 75,000 to get the answer that you're looking for. So 40% times 75,000 is 30,000 people. Okay, that is it for the notes for this lesson. Good luck with the exercises, and please let me know if you have any questions.